are going to see the question from signals and systems given in GATE 1993 from Laplace transforms concept. Here given that if the Fourier series Laplace transform f of s, that is given as the Laplace transform of f of t is equals to k by s plus 1 into s square plus 4, then we need to find limit t tends to infinity f of t is. So here it is nothing but this is the steady state value, that is we need to find the f of t at t equals to infinity, nothing but steady state value of the output f of t we need to find here. So by observing given that f of s, that is the Fourier, that is the Laplace transform of f of t is given as k by s plus 1 into s square plus 4 is given. So by observing here we have poles at s equals to -1 and we have poles at s square equals to -4, that is nothing but s equals to plus or minus 2j. So we have poles on the j omega axis, so we have poles on j omega axis. So if the poles on the j omega axis, as we know that if the poles lies on the j omega axis, always the curve will oscillate. We know that if the poles lies on the j omega axis, always the curve will oscillate, nothing but f of t is a oscillating function. Now oscillating function, the f of t is a oscillating function. So oscillating function is nothing but that varies between from some maximum value to minimum value. So that is throughout this time this f of t will oscillate between maximum and minimum value. So we can't define the steady state value for that f of t. So whenever the f of t is oscillating, whenever the signal is oscillating, that doesn't have the steady state value, then here limit t tends to infinity f of t is undefined, so we can't define that. Here it is undefined, so option D is the correct one here. So whenever it is oscillating, we don't have any steady state value, that always oscillate between maximum and minimum value, then we can't define the steady state value. That is option D here.